Hi, this is Mrs. Rodriguez, your geometry teacher. This video is a review for the Chapter 7 test that's coming up. What I suggest you do is that when a problem comes up on the board, pause the video, try to solve the problem on your own. If you can and you get the answer correct, great, move on to the next problem. If you get the wrong answer, try to figure out your mistake by following along with my explanation. And if you listen to the explanation and you still don't understand what you did wrong, please email me or stop by my office hours and I'll be happy to help you, okay, and answer your questions. All right, so we're going to go over some problems from a practice test that can be found in the textbook. So let me go ahead and just share that with you. So this is the Geometry Chapter 7 review. This is a practice test on page 500 of your textbook, okay? All right, so first section talks about proportions, and it says for any numbers a and c and any non-zero numbers b and d, a over b is equal to c over d if and only if when you multiply a times d, it's equal to when you multiply b times c. Okay, so in other words, when you cross multiply, if they're equal to each other, then whatever you're comparing, they're proportional to each other. Okay. So let's look at number 7. It says Jane is traveling to Europe this summer with the French club. She plans to bring $300 to spend while she is there. If $90 in US currency is equivalent to 63 euros, how many euros will she receive when she exchanges her money? Okay, so, oops, sorry. So we are comparing dollars to euros, okay? And we know that $90 is equivalent to 63 euros. And we want to know if she plans to bring $300, how many euros is that? So $300 is going to be our numerator. We're comparing dollars to euros. And then our denominator is going to be x. Okay, so then we would cross multiply. 90 times x is 90x. And then 300 times 63 is 18,900. And then this is a one-step equation, so we would divide both sides by 90, and x is equal to 210 euros. Okay? All right. Next problem. Our next section talks about similar polygons and triangles, okay? So two polygons are similar if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. Two triangles are similar if the angle-angle theorem, two angles of one triangle are congruent to two angles of the other triangle, or side-side-side theorem, where the measures of the corresponding sides of the two triangles are proportional, okay? And then side-angle side, the measure of two sides of one triangle are proportional to the measures of two corresponding sides of another triangle, and their included angles are congruent, okay? All right, so let's go ahead and look at some of these. It says determine whether each pair of figures is similar. If so, write the similarity statement and scale factor. If not, explain your reasoning. Okay, so what I recommend that you do, I don't know if you guys are visual. I'm not very visual, but I like to redraw the figures so that they look the same. So like right now, this one is straight up and this one is to the side, right? So I'm going to draw this other one. I'm just going to put it inside. This would be G, H, and this would be F, and this would be J. Okay, so in between F and G is 9, and in between G and H is 4. Okay, so now you can see that this long side corresponds to this side, and this short side corresponds to this side here. Okay, so I'm comparing the short side to the long side here of my rectangle. So for the first rectangle, I have the shorter side is equal to 4, and the longer side is equal to 9. And we're trying to figure out if that is proportional to this rectangle, the larger one. So on the larger rectangle, the shorter side is 10, and the longer side is 21. Okay, so if we cross multiply this, we end up getting 9 times 10, which is 90, and 4 times 21, which is 84, which they are not equal to each other. So we had to determine whether these figures are similar. No, they're not similar, okay, because their sides are not, we could say, the lengths of their sides, the lengths of their corresponding sides. Corresponding sides are not proportional to each other, okay? Because it does say to explain your reasoning, okay? All right. Next problem says to find x and y and then round to the nearest tenth if necessary, okay? So here we can see that this side here is equal to this side here because of these marks here. So that means if we're trying to solve for x, 3x plus 11 is equal to 5x minus 8. So then we're going to solve this equation. I'm going to subtract 3x from both sides. Then I get 11 equals 2x minus 8. Then I would add 8 to both sides, and I get 19 equals 2x. Then I would divide both sides by 2, and that would be 9.5 or 9.5 equals x, okay? And it says to find x, which we did, but it also says to find y, okay? So that would be these sides over here. So this side is going to be equal to this side. So 4y minus 7 is equal to 2y minus 1. So I'm going to subtract 2y from both sides. I get 2y minus 7 equals negative 1. Then I would add 7 to both sides, and I would get 2y equals 6. And then I would divide both sides by 2, so y is equal to 3. Okay? All right. Next problem, our next section talks about proportional parts. So if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional length, okay? And a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. And then two triangles are similar when each of the following are proportional in measure: their perimeters, their corresponding altitudes, their corresponding angle bisectors, and their corresponding medians, okay? All right, so here it says to find x and y and round to the nearest tenth if necessary, okay? So here it tells us that this side is equal to this side here. So I'm going to have 5x plus 8 equal to 21x. And then I'm going to subtract 5x from both sides, and I get 8 equals 16x. And then I would divide both sides by 16, and that would be 0.5 equals x, or 1/2 equals x, okay? And then over here, 20y minus 2 and 17y plus 3, these are also going to be equal to each other. So we're going to have 20y minus 2 equals 17y plus 3. So I'm going to subtract 17y from both sides. I get 3y minus 2 equals 3. I would then add 2 to both sides. So 3y equals 5. And then I would divide both sides by 3. So y equals 1.7 when I round it to the nearest tenth. Okay? Okay, moving right along. Here it says to find x, okay? Now, we can see that this angle is congruent to this angle, and this angle is congruent to this angle. So for the angle-angle theorem, it states that if two angles from a triangle are congruent, two of the corresponding angles are congruent, then the triangles are similar, okay? So if they're similar, then the lengths of their sides are proportional to each other, okay? So we know that this line here is equal to 18, and then this side of the triangle, this side of the triangle is equal to 21, okay? So the dashed line here that creates this 90-degree angle, the length of it on this triangle is 25, and the corresponding side from this triangle here is this one right here, the one that's labeled x, okay? So we have a proportion here, we can cross multiply. 18 times x is 18x, and 21 times 25 is equal to 525. And then you would divide both sides by 18, and x is equal to 29 and 17/100. So when you round it off, this is more than 5, so you're going to round the 1 up to 2. So it's 29 and 2/10. Okay. All right. Similarity transformations and scale drawings and models. So a scale model or scale drawing has lengths that are proportional to the corresponding lengths in the object it represents. Okay. So here it says Jimmy has a die-cast metal car that is a scale model of an actual race car. The actual length of the car is 10 feet 6 inches, and the model has a length of 7 inches. What is the scale factor of model to actual car? Okay, so we are comparing the model size to the actual size. Okay, so the model is equal to 7 inches, and the actual is 10 feet 6 inches. Okay, so we can write that, so they're both in inches, so that's 7 inches, and then 10 feet, well that's 10 times 12 inches per foot, that's 120 inches, plus 6 more inches, that's going to be 126 inches, okay? And we can simplify this, it's actually divisible, both are divisible by 7, so 7 divided by 7 is 1, and 126 divided by 7 is 18. So 1 inch in the model is equal to 18 inches in the actual size of the car. Okay. All right, and then the next section talks about types of dilation. So there's an enlargement. So when you have a small figure, and then you enlarge it, and then you can determine the scale factor, okay, of the enlargement, or you can have a reduction. So when you're going from a large figure to a smaller figure, and you can also figure out the scale factor for that as well, okay? So let's look at one of these. It says to determine whether the dilation from A to B is enlargement or reduction, okay? So first, from A is this larger triangle, and then B is this smaller. So if we're going from large to small, it is going to be a reduction, okay? Then it says to find the scale factor, okay? So to do that, we need to figure out the distances between the vertices, okay? So for example, this point here to this point here. And then, so this point here is -6, +8. And this point here, the coordinates are 4, +8. So the distance, it's going by increments of 2. So we can just count 2, 4, 6, 8, 10. So the distance here is 10. And then from here, from negative right here, from this point to this point, so the corresponding vertices of the triangle, okay? So the coordinates of this point here are -3, +4, and over here is +2, +4. So the distance here, this from here to here is 1, and then +2 is 3, +2 is 5, okay? So the distance there is 5, okay? And so we are comparing B over A, okay? So B, the distance was 5, and the distance from the vertices in triangle A was 10. So we can simplify this by 5, and we end up with 1/2, and that is the scale factor, okay? All right, and then this one, it says determine whether the dilation from A to B is an enlargement or reduction. So here's square A, and then here's square B, so obviously it's bigger, so this is going to be an enlargement. So to find the scale factor, we're going to figure out the distance between the vertices, okay? So here, notice here, this is the origin here, this is 0, okay? So we're going to find the distance between this point and this point, okay? So the coordinates of this point are -4, I'm sorry, we're going to look at this point and this point. So -4, sorry. All right, let me just change color. Okay, so we're comparing this point here, which is -4, -2, and the distance to this point here, which is -6, -2. Okay, so the distance is 1, 2. Okay, so the distance is 2. And then we're going to look at these 2 points, the distance between these 2 here. So this one here, the coordinates are -1, -5. And then over here, this is going to be -6, -5. So the distance is 1, 2, 3, 4, 5. Okay. So again, we're comparing B over A. So B is 5, and then A is 2. So the scale factor is 5 over 2. Notice it's left as a fraction, okay? All right, next problem says to identify the similar triangles and then find WZ and UZ, okay? So if looking at these triangles, if this is a 90-degree angle, then this over here is also going to be a 90-degree angle. So like I told you before, I'm not a good visual person, so I need to redraw these figures. So this triangle right here is fine, okay? But I want to see this triangle facing the same direction. Okay, so I want it to look like that and then label it. Okay. All right, so there's that one, and then there's this one. So this triangle, the right angle is U, and then this angle is W, so this side has to be Y, okay? All right, and then I know that the length of the side between W and Y is 16, and the length of the side between U and Y is equal to 12.8. Okay, I don't know this side. I'm asked for WZ, this side over here. Okay, and then UZ, this side over here. Okay, so what we need is to write the corresponding sides. So I know that WZ, side WZ, and side ZU. The corresponding side to WZ is going to be YW, okay, on this triangle, on the other triangle. And then the corresponding side to ZU is going to be WU, okay? So then I'm going to fill this in with the corresponding values. So the length of WZ is equal to x plus 4. The length of ZU is equal to x minus 0.8. And then here, get YW is equal to 16. Now the length of WU, we need to figure out the length of WU. Well, the good thing is that this is a right triangle. And if you remember Pythagorean theorem, a squared plus b squared equals c squared. Well, I know that my a value can be 12.8 squared, plus I don't know my b value, but I know that c, the hypotenuse, is equal to 16. Okay, so this 12.8 squared ends up being 163 and 84 hundredths, plus b squared equals 16 squared is 256, and then you would subtract 163 and 84 hundredths, and then you would get b squared is equal to 92 and 16 hundredths, and you take the square root of both sides, and you actually get a pretty okay decimal of 9 6/10. Okay, so I can put 9 6/10 as the length of WU. Okay, all right, so now I need to cross multiply. So I'm going to be multiplying 9.6 times x plus 4 and 16 times x minus 8/10. Okay, so this ends up being 9.6x plus 38.4. And over here I have 16x minus 12 and 8/10. Okay, so now I've got an equation here. I can subtract 9 6/10 x from both sides. This ends up being 38 4/10 is equal to 6 4/10 x minus 12 8/10. Then I would add 12 8/10, and I end up with 51 2/10 equals 6 4/10 x, and then I would divide by 6 4/10, and I end up getting 8, exactly 8. So I know x is equal to 8. Okay, well that's helpful, but remember I need to find WZ. Well, I know WZ is equal to x plus 4. Okay, let me change colors here. So I know that WZ is equal to x plus 4. Well, I just figured out that x is equal to 8. So it's going to be 8 plus 4. So WZ is equal to 12. Okay, so I found WZ. Now UZ, change colors one last time. UZ is equal to x minus 8 tenths. So we just figured out that x is equal to 8. So that would be 8 minus 8 tenths. So UZ is equal to 7 and 2 tenths. Okay? So make sure, if you have a problem like that on the test, if you solve for x, make sure you actually answer what it is that you're looking for. Because I guarantee that one of the answers will be x is equal to 8. Okay? And you'll think, oh, there's my answer. So, but make sure you read the question and you answer what it's actually asking. Okay? All right, next problem talks about maps, and this is an additional practice problem, so it's not in the practice quiz, but you will have one very similar to one like this on the test, okay? So it says a map of the eastern United States has a scale where 3 inches is equal to 25 miles if the distance on the map between Columbia, South Carolina, and Charlotte, North Carolina is 11.5 inches. What is the actual distance between the two cities, okay? So you know that 3 inches is equal to 25 miles, okay? We're going to set up our proportion. We want to know what 11.5 inches, how many miles is that going to be, okay? So we would cross multiply. 3 times x is going to be 3x, and then 25 times 11.5 is 287 and 5/10, and then you would divide both sides by 3. And x is equal to 95.8, and this would be miles, okay? So in real life, it is 95 and 8/10 miles. On the map, it's only, those two cities are only 11.5 miles apart, okay? 11.5 inches apart, excuse me, okay? All right, so let's look at another problem here. Again, this is an additional practice problem, so you will have one very similar to this on the test, okay? So this says to estimate the height of a tree, Dave stands in the shadow of the tree so that his shadow and the tree's shadow end at the same point. And Dave is 6 feet 4 inches and his shadow is 15 feet long. If he is standing 66 feet away from the tree, what is the height of the tree? Okay, so we've got this tree. Okay, and then we've got Dave. Here's Dave, okay? He's got some spiky hair, okay? All right, so there's Dave. He is standing 66 feet from the tree, okay? All right, and then his shadow is 15 feet long, okay? So from here to the end of his shadow is 15 feet long, okay? And then we know that he is 6 feet 4 inches tall, okay? So here, what we end up having, we want to know the height of this tree. We want to know the distance from here to here. So what we end up having is this right angle, okay? And his height, Dave's height, and his shadow are also forming another right triangle, okay? So the lengths of their sides are going to be proportional to each other, okay? So we're comparing his height to the length of the shadow, okay? So he is 6 1/3 feet because he's 6 feet 4 inches. So 4 inches out of 12 inches in a foot. You can simplify that. and that ends up being 1/3. So he's 6 1/3 feet tall. And then his shadow is 15 feet long, okay? Now we're gonna compare that to the tree, right? The tree, we don't know the height of the tree, okay? But we know that the shadow of the tree is 66 feet plus another 15 feet, which ends up being 81 feet, okay? So we're going to cross multiply. 15 times x is 15x, and 6 1/3 times 81 ends up being exactly 513, okay? So now we've got a one-step equation. We would divide both sides by 15, and x is equal to 34 2/10 feet, okay? That is our final answer there. Okay, so that's all the problems. I thank you for watching, and please, 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 if you have any questions or you're confused about any of the problems, please stop by my office hours and I'll be happy to help you. Make sure you're checking the calendar to make sure there aren't any reviews coming up. You might have to schedule like a separate time if you have questions, because I have several reviews coming up this week. But if not, always email me. And you can find out that way as well, or ask your question, and I can help you via email as well. I can do like a quick video and email it back to you. Okay. So once again, please, I'm here to help. Please reach out. Okay. You have a great day.